Hello, everybody. I'm going to take you through a very quick and high-level view of how to accelerate developing and deploying your Linux-based products, with particular reference to the European Cyber Resilience Act. And also a lot of the mistakes that we see companies make when they build products and how to hopefully avoid those mistakes. So I'm going to talk a little bit about what is an Edge AI device. We all know how to select hardware, but we're not very good at working with software companies before we choose the hardware. And that actually can cause a lot of problems in deployment and a lot of cost in terms of technical debt. And then, what are the implications of the EU Cyber Resilience Act? There's been a lot of talk about this. I'll give you a very quick summary, and then we'll close. So, what is an Edge AI device? Well, pretty much everything. You can have light bulbs, you can have sensors, you can have cars, robots, spaceships, anything that has computing inside, any connected device. Indeed, often non-connected devices. You may have a secure factory where you don't want to be connected to the internet, but you've still got devices that are critical for your business need. So anything, smart homes, smart cities, toys, glasses, robots, etc. And hardware selection, this is critical. Now, most companies, whether they're startups or big companies, they choose the hardware. There's a whole bunch of criteria, which we'll come to in a moment, and then they hand the hardware prototypes to the software team and say, go make this work. And so typically, when you're evaluating building a product, you're either using off-the-shelf hardware solutions, or you're doing customized designs. So a customized design might use a system on module. So if you're building 1,000, 10,000 of something, it may be less expensive to use a SOM, like a SMARC module, than actually building your own design chip down. If you're in high volume, it's probably less expensive to actually design your own chip down device. And so there's a lot of things to consider here. Supply chain factors, single or multiple source. You may not want a single source. You may be quite happy with your single source. Manufacturer location, geopolitics. We're starting to be concerned about sourcing components from different parts of the world. So sourcing from China may be a problem depending on what's in that chip. And for Chinese companies, sourcing in America may be a problem. So you have to consider manufacturer location. And then future component availability. If you're building a product with a lifetime of 15 years, you need to know that that chip you're using today is going to be deployable or purchasable in 10 years' time. And of course, cost. An awful lot of purchasing decisions or hardware decisions of what to put in your product are made basically on cost. The lower the cost of hardware, the lower the cost of the product, right? No. The most expensive part of product development for most IoT products, and the place where most of them fail, and most do fail, is actually in software deployment. So we'll talk about that in a moment. So additional considerations that sometimes you don't think about when you're developing or speccing a product: processing power, memory, and storage capacity. If you think about developing an IoT project for smart city, that's going into a home or an office building, that's going to be there for the next 10, 15 years. The world moves on at a huge pace in the next 10 or 12 years. Do not design just to fit today's software in. Yes, software will get more efficient, it may get smaller, but the track record so far is that you should probably design, depending on how long you need to support your product, for at least another 10 years and maybe double the memory capacity, double the storage capacity, and so on. And then new considerations are around security. So we'll come to that. As I said, mostly companies actually build the hardware and then hand it to the software department. This is not a good idea, because when you actually start to think about software, you really need to consider software before you make your hardware choices, and I'll explain why in a moment. But software is very dependent on your application. For lights and sensors and small devices, you have RTOSes. So Zephyr, open source, FreeRTOS, open source, ThreadX, open source. For more powerful devices, anything from gateways to robots to smart toys, smart devices for the home, you're looking at Linux, Android, Windows. And if you choose Linux, and the reason for doing that is it's completely open source, you have complete control of what you do, you then have an extraordinary choice of which Linux distro. Do you build your own? Do you use something off the shelf? As developers, we've all liked to use Debian or Ubuntu, but there's plenty of other choices depending on your application. And there's build your own distro. So Yocto is for a toolkit for basically building Linux distros. And things like Qualcomm Linux, Foundry's LMP, Linux Microplatform, or bring your own do-it-yourself distros can be built with Yocto. Why would you consider doing it yourself as opposed to using something off the shelf? There are a number of reasons. Firstly, that you are effectively creating a managed device. Think of Alexa in your home, or the Google equivalent, or Siri. Those devices are managed by a service provider or by the supplying company. It's very different when you are, as an end user and a developer, in control of just saying, well, I want to apt-get that. I want Python on this, And if you can do that as an end user, it's probably not a good idea if you're actually running a managed device. The other thing you have to consider for managed devices is licensing. So GPLv3 is in a lot of open source code. There are rules about what you must do if you have GPLv3 in your product. You must enable the user to be able to replace that with their own version. You probably don't want to do that if it's a mission-critical device that you're installing into an office or a smart city or a piece of medical equipment. So you have to get rid of all of that. And there's a lot of GPLv3 code in many Linux distros like Debian and Ubuntu. You also have to consider commercial use licensing. If you use Ubuntu and you modify it and you ship it in a product, you technically you have to have a commercial arrangement with Canonical, who are the stewards of the Ubuntu platform. And then you have to consider update of devices. So when there are new versions of the operating system available, it can take a lot of effort to make sure that the operating system that you're providing and the functionality that you're delivering are in lockstep. So some of the questions that you should ask your vendor of hardware, for off-the-shelf products, it's very important to reduce your costs that your hardware is supported in upstream Linux, in kernel.org. How often do you update the OS for this hardware? So if you're buying an SoC, or you're buying a Wi-Fi chip, or a Bluetooth chip, or a LoRa chip, are you going to commit to updating that software for the next 10 years? Do you include, how often do you update the OS? Do you include the boot firmware? Boot firmware is often very proprietary, often not open source. Is your boot firmware open source? Can I update from one version of the operating system to the next version over the air? If you can't, you're going to have to build all that technology in yourself. That's very expensive. It's technical debt. You're going to be maintaining that software for 5 or 10 years. How do you deal with critical CVEs, so critical vulnerabilities? They turn up. We don't know what we don't know. It may actually not be software that's the problem. As software engineers, we like to think we can create perfect software. No bugs, ever. Well, technically you can, but you still don't then be able to deal with something like spectral meltdown, where the problem is actually a vulnerability in the hardware, even though you've written perfect software, which of course none of us do. So you've got to reckon that you are going to have to update your product. You can't anymore just say, this is a closed system, I've tested everything on it, it's never going to fail, it's okay. No longer, because we're connecting everything to everything. So What do you do about critical CVEs? You should be asking every single hardware component vendor you are talking to, anybody who's got any software in their chip at all. And then for the SoC vendor, do you support secure boot? Secure boot is making sure that when you boot your software, it is actually the software that you think it is and not somebody who's actually injected something into it. And ask for a demonstration. Seriously. Right? Because it's very easy to say yes and not be able to do it. So for chip down and custom designs, is your hardware supported in upstream Linux? Because that will save you a huge amount of money and time. And does this include the SoC and all peripheral components that you're using? And the answers, as I say, will directly affect the time and cost and the lifetime maintenance costs of your product. The more software you create yourself, the more you have to customize, the more technical debt you're going to carry for the lifetime of that product. So let's now consider software and applications. There is an industry trend towards using containers for applications and services, and particularly Docker. And think of this as the equivalent of the App Store for mobile phones, but this is for industrial and edge applications. And the key benefits of using containers, like in the mobile phone space, is it separates the applications from the operating system. You may want to update your applications quite a lot. You may want to update your AI models. You may want to update functionality and deliver new functionality or different functionality to different customers. So keeping the applications separated from the operating system is basic hygiene and also enables an applications ecosystem to develop, even in the industrial space. And so the other benefit is that you can then update your applications and services, just like on your mobile phone, without rebooting the device. And in some areas like robotics, that's extremely important. You don't want the drone falling out of the sky because it's got an update. Okay, what changes with the CRA, the Cyber Resilience Act? Basically everything. We used to be able to ship products without securing them. That's no longer going to be possible. Devices must be secured or you're going to potentially have fines of millions of euros. You're going to have to implement secure boot. No default passwords, public key encryption, data encryption. You need process. It's not just a technical problem. You also need to establish processes for monitoring, addressing, and reporting security breaches and vulnerabilities in your product, and monitoring those vulnerabilities and reporting to the nation states when you have a problem. And updates have to be made available for your product for the longer of 5 years or the product lifetime. Key dates here: by the September of next year, you must be reporting actively exploited vulnerabilities, i.e. if somebody finds a problem or you find a problem in existing products. And by December 2027, you've got to be fully compliant to the CRA for anything you ship. That's not very far away. Some of the technical issues, you can look at the slides hopefully afterwards, must be secure by default. There must be no known vulnerabilities when you ship it. You must be able to reset it to the original state. Automatic updates must be available. The user can opt out or postpone them. You must encrypt data, must have encrypted file systems. You must limit attack surfaces. You must have a software bill of materials so that you can monitor vulnerabilities. And you must make security updates available for 10 years after you've first issued them to people who may be using those products 10 years later. And you've got a lot of process to worry about: record keeping, software bill of materials, reporting audits, and reporting to customers and authorities with deadlines. If you don't meet the deadlines, you can be fined. So how do you do this? This is a lot for any company to take on. And if historically we haven't bothered to secure products because it's too difficult and it takes too long and it's too expensive, that's no longer possible. We're going to have to get our act together here in this industry. So how do you do this? Well, you can do it all yourself. There's a lot of learning to do and a lot of work to do. I'm sure consultancy companies like in the Y2K and all of the other things that are the ISO 9000 and so on, there will be a lot of money made in consultancy companies to help companies actually deal with this. The OS providers are also going to be a key source because they're providing software that you're going to be putting into your products and delivering. Now, the person who's ultimately responsible is the person who's shipping the product in the European country. This is not just going to be a European issue. The US are going to be following pretty hard on that. And then SOC and SOM vendors can also help you. So we, as Foundries, this isn't a plug, but there are companies in the software space who have open source-based cross-architecture tooling to help meet the requirements of the CRA. Things like automatic delivery of SBOMs, things like unique builds that are actually auditable for every time you do a build and deliver it to your devices. Over-the-air updates securely. Security of those over-the-air updates is critical. And then device and fleet management. So how do you properly roll out to tens of thousands, millions of devices, just like you were updating your iPhone or your Android phone? The primary responsibility for meeting the CRA is with the device maker, but ask all your software providers, what do they provide to help you meet these requirements? So that's it. It was a bit of a lightning tour around what you should and shouldn't do when you're thinking about developing a product. But please, if there's one thing you take out of this talk, it's this. Do not choose hardware without consulting software experts in your company or in your suppliers. If you don't do that, you could be facing significant additional costs and significant delay in time to market, both of which are critical to the success of your IoT and Edge product. And with that, I finish. Thank you very much.